warahmatullahi wabarakatuh. My name is Cikgu Syazah Marisa with Cikgu Ahmad Rizal. Okay, so today I'm going to present about complete X-ray unit. Okay, so before we go to the main component of complete X-ray unit, okay, so I will show you guys. Okay, so if you can see at this, okay, we use the modality of ceiling mounted X-ray machine, and then at this we use the ray wheel track. This is the way to move the X-ray tube free to all. So I will start the first component, which is generator. Okay, so basically the generator is function to supply the electrical energy to the X-ray tube. Okay, so basically in this generator we have step up transformer, and then capacitor, rectifier, high voltage circuit, and also control panel. Okay, so this next component is connected by the X-ray tube, which is high tension cable, or we call HTC. Okay, so in this cable we have cable positive and negative, and then the function is to carry the high voltage current from the X-ray generator to the X-ray tube. So basically this tube arm is to hold the X-ray tube to go everywhere in this room. Next we move to this component. Okay, so this is X-ray tube. Okay, so basically in this X-ray tube we have many components in it, but this is the glass envelope is the casing or the cover of the tube housing in this X-ray tube. Okay guys, we go to the next component, which is the aluminium filtration. Okay, here we got the X-ray tube, and here we got the LBD, which is light beam diaphragm. Okay, so between on this X-ray tube and this LBD we have the aluminium filtration between on this. Okay, so the function of the aluminium filtration is to filter the unnecessary radiation of the low beam energy of radiation, because we only need the high energy of radiation, okay, which is the polychromatic. Okay, why we don't need low energy photon? Because the power not enough to penetrate the internal tissue for captured by detector. It just only absorbed, so the image cannot be seen. So back to our principle, which is the X-ray beam pass through the patient captured by detector. So that's why we don't need low energy of photon, and includes the function aluminium filtration. Okay, and then here we have a collimator, and this light we call light beam diaphragm, which is LBD, to control the exposure of radiation, to expose a film and create a radiograph to inspect a material for defects. So if the LBD is missing or damaged, how do we know large area of radiation is exposed to? So that's why the collimator and the LBD are important for us, to our guide, also to control the radiation. Okay, here we have some button to move the X-ray tube. Either we want to move the X-ray tube up or down, or in front or back, and then to the right or left. Okay, in here we got some button to return the tube like this, also like this. Okay, in here we got the button for angulation. Okay, whether we want to angle up or angle down. Okay, and the last button in here we got the free button. When we push this button, we can move the X-ray tube everywhere we want to go. Okay, so this component is erect bucky. So basically this component is function to capture the image, and then here we have a grid. Okay, so basically the grid is function to absorb the scattered radiation. Also, we use the grid to get the good quality of image. Okay.
Assalamualaikum warahmatullahi wabarakatuh. I am Muhammad Amir Aiman bin Mizanur Rahman. So today, I would love to share to you guys about the X-ray control panel. So, the X-ray control panel is a machine that will change the kV, MAS, also the millisecond of the X-ray tube. So, what is the function of the kV button? kV button is the button that will change the energy for the penetration of the X-ray energy. After that, the milliampere per second. Milliampere per second is the current flow of the electricity of the electric beam. Last but not least, the millisecond. Millisecond is the speed of the penetration from the X-ray beam. So, for the millisecond button, it is used to control of how long the penetration will taken for the patient. After that, it also have the rotary dials. The function of the rotary dials is to minimize the time taken of one procedure. After that, the functional button at here also have the on-off button for the X-ray panel. After that, the AEC button, home, lock and also setup. So, it also consists of the AEC button. AEC button is used to maximize or optimize the radiation of the exposure for a patient. It also will reduce the scattered radiation for the patient. After that, it also consists of the home button. Home button is used after we finish one procedure. Next, the lock button. Lock button is used to see the history of the radiation that we exposed before this. Last but not least, the setup button. So, after that, we also have the blue light ring indicator. Blue light ring indicator is used to show whether the X-ray control panels is on standby mode or activating mode. After that, we also have the small circular button. Small circular button is used to adjust the collimation for the patient. After that, we also have the hand or the click button. Click button is used to activate the X-ray control panel and after that, shoot the radiation for the patient. I think that's all from me. Thank you. So, right now, I want to share to you guys about how the APR system works for this X-ray control panel. First of all, here, we have the erect Baki button. So, it consists of the shoulder positioning, humerus positioning, it consists of frontal and lateral, knee joint, elbow, radius and also ulna, and last but not least, the chest. After that, I want to share to you guys about other projection for the anatomy of our body. Next, we have the skull, frontal and also lateral, thorax, frontal, lateral and also oblique, Towns view, lumbar view. For the lumbar, it also consists of the frontal, lateral and also oblique. Other than that, we can see that it also consists of the cervical vertebra. It consists of the frontal, lateral and also oblique. So for now, I will love to share to you guys about the function of the APR. First, preset parameters. APR system come with pre-programmed settings for various anatomical regions such as chest, abdomen, and also spine. These parameters includes values for KVP, MAS, and sometimes focal spot size or filters. Other than that, it also user-friendly interface. Radiographer or technologists can select the body part and view there are imaging such as chest PA on the system console. The system will be automatically adjust the machine to the optimal setting for that specific examination. For the number three, customization. Through parameters are preset, they can often be adjusted manually based on patient size, condition, or other specific needs. Other than that, consistency and also efficiency. APR ensures consistent image quality across all examination. It reduces the time spent manually setting up exposure factors by the radiographer, so it will improve the workflow efficiency. After that, it will minimize the errors. By standardizing settings, APR reduces likelihood of incorrect exposure parameters, which can lead to poor image quality or the need for repeating of exposure. Last but not least, the radiation safety. Optimized settings help in minimizing patient radiation exposure while still achieving diagnostic quality images. Next, I will share to you guys about the components inside the APR system. First of all, it consists of the software components. Pre-programmed protocols such as APR systems come with a database or preset exposure parameters for specific anatomical region and views such as chest PA, lateral spine, and also abdomen epi. These protocols include parameters like KVP, MA, exposure time, and automatic exposure control AEC setting. It also comes with the customization features. Users can modify or update the setting based on the patient size, condition, or specific diagnostic requirement. The user interface. It comes with the touchscreen or control panel, a graphical user interface (GUI), allow the radiologic technologists to select body parts and view from an intuitive menu. It comes with the parameter display tool, displays selected KVP MA, exposure time, and also focus spot for the time confirmation. For the third one, integration with the imaging system hardware. X-ray generator. For the X-ray generator, the APR system communicates with the X-ray generator to deliver the correct exposure parameter. For the automatic exposure control AEC, APR often integrates with the AEC system to adjust the exposure time automatically, ensuring the optimal image quality. After that, the collimator control. Collimator control may be adjust the X-ray beam size and shape for the specific anatomical view. Next, for the sensors and detectors, digital or analog detectors will cause the APR settings are optimized for use with specific image receptor system such as detectors, computed radiography CR plates, or film cassette. For the feedback mechanism, works with the sensor to adjust exposure dynamically, such as detecting over penetration or under penetration. Last but not least, the safety features for the APR components are error alerts, built-in algorithm check for inconsistency or unsafe parameter combination. For the radiation dose, it will optimize the radiation exposure by recommending optimized setting for each body part for the patient. So, for now, the conclusion already arrived. The conclusion is APR is particularly useful in busy radiology departments where a wide variety of examinations are performed. It allows the technologist and also radiographer to focus more on patient care rather than technical adjustment to ensure the quick and accurate imaging. Other than that, it also optimizes the image quality that we perform during the procedure. I think that's all from me, Muhammad Amir Aiman bin Zainur Rahman. Thank you so much for hearing.
Hello and Assalamualaikum. My name is Nur Amin Shazwani. Binti Zahiri. I'm from Group 12 and I will proceed and explain about the X-ray tube and its specifications. The meaning of an X-ray tube is a device used to produce X-rays which are high energy electromagnetic radiation.
It consists of several key components, each designed to perform specific functions to generate X-rays effectively. Therefore, this is an explanation of each components and specifications. For the first one component is cathode, which is negative electron. The cathode consists of filament usually made of tungsten and a focusing cup. The filament is heated to produce a cloud of electrons through thermionic emission. The focusing cup directs the electrons toward the anode. Number 2 is an anode, which is positive electron. The anode is typically made of tungsten or molybdenum, as these materials are capable of withstanding high temperature and have high atomic numbers, which helps in producing efficient X-rays. The anode serves as the target for the electrons from the cathode. When the electrons strike the anode, they are rapidly decelerated, which leads to the production of X-rays via brainstem and characteristic radiation. Number 3 is glass or metal envelope. The tube is sealed in a vacuum-sealed envelope to allow for the free movement of electrons. The vacuum also prevents the scattering of electrons due to the air molecules. Number 4 is an X-ray tube housing. The housing contains lead or other radiation-absorbing materials to shield users from excess X-ray radiation. It also serves to dissipate the heat generated during X-ray production. Number 5 is high voltage transformer. A high voltage power supply is used to accelerate the electrons from the cathode to the anode. The voltage typically ranges from 30 kV to 150 kV or more, depending on the application. Moreover, the specification of X-ray tube is number 1, tube current, which is ME, measures the flow of electrons from cathode to anode, affecting X-ray beam intensity higher ME, equal more X-ray photons and higher radiation loops. Number 2 is tube voltage, which is kV. The voltage between the cathode and anode controlling X-ray energy and penetration. Higher kV equal to stronger X-rays that penetrate denser materials. Number 3 is anode target material. Determines X-ray efficiency and energy. Tungsten is common for general imaging, while molybdenum and rhodium are used in mammography for softer X-rays. Number 4 is focal spot size, the area where electrons hit the anode. Smaller spots improve resolution but generate more heat. Larger spots handle more current but reduce sharpness. Number 5 is heat capacity. The ability of the tube of dissipate heat, high heat capacity, is crucial for high power X-ray production. Number 6 is filtration. Remove low energy X-ray from the beam to reduce radiation dose and improve image quality. Number 7 is X-ray spectrum. The range of X-ray energies produced. It varies with the tube voltage, target material, and filtration, from continuous to characteristic radiation. Last but not least, for the specification is cooling system. Prevents overheating by dissipating heat generated during X-ray production, often with oil or water cooling in high power systems. In conclusion, an X-ray tube is a complex device with multiple components that work together to generate X-rays for various imaging applications. Its specifications such as tube current, voltage, anode material, and focal spot size are essential in determining the quality and utility of the X-ray output for medical, industrial, and scientific purpose. Okay, hi and assalamualaikum. My name is Mia Amir Shazmani binti Zuhairi. Today, I will tell and show to all of you guys about the functions of each buttons on the X-ray tube. But today, I'm not alone because I'm bringing our junior from Diploma in Medical Imaging, Sem 1. Okay, you can introduce yourself.
Hi, my name is Aidala Safian, but you can call me Fia from Sem 1 Diploma in Medical Imaging.
Okay, Fia, did you know about the functions of each button?
Okay, since she doesn't know about the topic today, so I will tell her, and for those who didn't know yet, you can watch this video until the end.
This is, we call it as SAQ. So for the first button, for patient who cannot do a true lateral, so we can use this button to move it like this.
This is an example for a patient who cannot do a lateral projection because of fracture or pain. So we can do a rotate following a patient's feet. But here, we must use the angles button too. So the end of the result from a patient's feet is not in true lateral, and now patient's feet can be in a true lateral projection. For your information, don't forget to put an anatomical marker when do an X-ray.
Do ba 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 do boo do a boo ba do ba do boo boo ba do a do ba do ba do a do ba do ba do 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 a do ba do ba do a do ba do ba do ba do ba do.
For this button, we can only go up and down. So as you can see, when we go up and down, the distance will change. For the third button, we can do the angulation, either 90 degrees or something else. For 90 degrees, we used to do a chest X-ray. For this button will emit the laser light, so we can center to the side. This button we can use to do a left and right. This button or we to do a free movement. So we can do this and backward, go up and down, go right and left. Okay, last but not least, this button only can go to the forward and backward.
Okay, that's all from me. Bye.
Assalamualaikum and good day everyone. I'm Nafis Omar by Nafizwal, and today I'll be presenting about an X-ray generator in a complete X-ray unit and how does it work and what is the key component of an X-ray generator unit. First of all, what is an X-ray generator unit? So, X-ray generator unit is a device that will produce an X-ray for the purpose of scientific research, industrialization and medical imaging. And for this context, we are in a computer radiography room and the X-ray we use for the diagnostic imaging. And the function of X-ray generator is to convert the energy of kinetic to the X-ray energy. And first of all, we're going to start from the X-ray tube, from the production. So, first of all, what is the key component of the X-ray generator unit? First of all, we got an X-ray tube right here that contains cathode and anode. Which, bear in mind, the cathode one is the negative side of the X-ray tube and the anode side is the positive side of an X-ray tube. And second one, we got a height generator that will provide a high frequency power supply to the X-ray tube. We got an X-ray unit control panel which can be used to manipulate the KVP, the MAS and the MSAT for the diagnostic imaging according to the body part and the exposure needed for the patient. For this machine that we use in our hospital to Intan, which is the Shimazuan, they use an air cooling unit instead of the air. They use the air cooling unit instead of the water and the oil one. As you see right here, the function of the cooling unit for the X-ray unit is to dissipate the heat across the X-ray unit so the machine can be used throughout without any breakdown and increase the durability of the machine. So, for your information, just a little bit of information that we're going to talk about the cooling system. As we already know that when the X-ray energy produced, only 1% will be not useful for the diagnostic imaging, but for the other 99, it will dissipate as heat. So, a fully functional X-ray cooling system is really playing a major functional purpose in producing an X-ray for the diagnostic imaging. So, in order to understand how does an X-ray generator work, we gotta dive back into the how an X-ray beam happens. So, first of all, the height generator power supply, we supply a high frequency electric across the X-ray tube by using the first one, which is the cathode one. So, bear in mind that there is a filament that will emit an electron when heated, and there is the cathode, which is the negative side. The one is the anode, which is the positive side, and will be the target for the electron bombardment from the cathode side. And the anode one is take shape in a rotating disc that will serve as a focus spot for the X-ray beam generation. And this whole process can be called as a thermionic emission, and that one I'm going to talk about later. And right now we are going to talk about what is a thermionic emission and how does a thermionic emission works. As I mentioned previously, the thermionic emission refers to process which is the electrons are emitted from a material that is usually metal of semiconductor. So in this context, it's a filament at the cathode side that gonna be heated by the high energy power supplied by the X-ray generator, so it will emit an electron. So as I mentioned previously, because of the high energy that is supplied by the X-ray generator, it will hit the filament, the negative side of the X-ray tube. So because of that, an electron will be freed because of the heat, and because of that also, there's a form of energy that has been created, and that is the heat energy. So that heat energy that we mentioned previously will be converted into a kinetic energy. So the kinetic energy will accelerate the electron more to the bombardment area at the anode disc. So there is a factor that could affect how the thermionic emission works. So the first one is the temperature. In this context, is the temperature of the X-ray tube, or more precisely the filament. So the higher the energy that has been supplied by the X-ray generator, the higher the temperature. Thus, there are more electrons that will be free because of the thermionic emission. So we're going to talk about the two types of X-ray production at the anode side. So right now, I'm going to talk about two types of possible outcome when there is an electron bombardment at the anode disc. That is, to be exact, at the focus spot. So the first one, we got the Bremsstrahlung radiation, or in other words, it's a braking radiation. So Bremsstrahlung radiation refers to when the electrons from the cathode are decelerated or deflected by the strong electric field of the anode atomic nuclei. It will emit an X-ray energy with a continuous spectrum of energies. And the second one, we're going to talk about the characteristic radiation. So what is a characteristic radiation? So I'm going to explain about this characteristic radiation in a simplified version, and so that you guys can understand it more clearly. So characteristic radiation is refer to when a scenario, if the electron have sufficient energy, they will eject an inner shell electron from the anode atom, from the cycling around the atom. So if that happen, the outer shell electron, or should I say the free electron, will fill the vacancy in the inside the ring of electron that circulate around the atom, and at the same time it will release an X-ray with specific type of energy. I want to tell you about the three types of X-ray generator that widely used around the world. So the first one, we got single phase generator. So what is a single phase generator? So single phase generator is the most basic design of X-ray generator of them all, which I say that is less efficient than the three phase and the high frequency one because of the ripple that will be produced when the X-ray generator is working. As as we already know, the cathode side of the X-ray tube is a negative side. But on the other hand, the anode side of the X-ray tube is a positive side. So the cathode, which is the negative side, will repel the electron, and the anode side, which is the positive one, will attract the electron. So the acceleration of the electron can happen in the speed of light in the vacuum seal X-ray tube, which is the speed of 3 times 8, the power of 8. 3 times 10 and the power of 8 millisecond. So when the acceleration happens, there's a form of energy that created, which is the kinetic energy, and later the kinetic energy will be transformed into an X-ray energy. It is also the older generation of X-ray generator, so it will be less efficient than a 3-phase and a high frequency one. The second one is a 3-phase X-ray generator, which is much more efficient than a single-phase generator because it will provide a smoother voltage compared to the single-phase generator, and also produce more efficient X-ray generation and high quality image, thus enhancing the quality of the image produced. And the last one, I'm going to talk about the high frequency X-ray generator, which is the modernized version of the previous. Most of the previous X-ray generator that I talked about, which is the single phase and the triple phase, and it's much more efficient and much more convenient to be operated compared to the previous one. High frequency X-ray generator also produce almost constant voltage and reducing the ripples compared to single phase and third phase and the triple phase, and also at the same time enhancing the image formation and the image quality in the radiology department. So lastly, I'm going to talk about the importance of having an X-ray generator that fully functional and optimum condition in the X-ray department or radiology department. So the first one, the quality of image. Having a fully functional and optimum or the modernized version of X-ray generator in the radiology department will sure will enhance your image formation, and also at the same time will avoid a reject failure. Second one, ensuring the patient safety. By having a fully functional X-ray generator unit, we will manipulate the dose, or should I say the KVP, MAS and the exposure dose to the patient, and at the same time minimizing the unnecessary radiation to the patient. Lastly, the machine durability. So having a fully functional X-ray generator unit could prolong the life of the X-ray tube, and also could enhance the workflow and smoothing the workflow of the X-ray radiology department, because of the time will be not too consuming compared to the other X-ray generator unit. That's all for today, folks. So I hope you enjoy the video and leave some question at the end of the presentation. Thank you.
Hi, Assalamualaikum. My name is Najwa Farhanis. Now we proceed to my part, which is line focus principle. Okay, in this part, we will learn about what is the line focus principle is, how it is work, and what is important in radiographic imaging. Okay, what is a line focus principle? The line focus principle is a design concept used in X-ray tubes to improve image resolution while managing heat dissipation. It involves angling the anode target so that the effective focus spot appears smaller than the actual focus spot, improving image sharpness without overheating the anode. How does the line focus principle work? When electrons from the cathode strike the angled anode, they create the actual focus spot, which is larger and help distribute heat. However, due to angle, the effective focus spot, which is the size of the X-ray source as seen by the patient of detector, is smaller. This smaller spot enhances spatial resolution. Typically, the anode is angled between 7 and 20 degree balance since heat dissipation and image quality. Okay, what is important of the line focus principle? The line focus principle is critical because the first one, a smaller effective focus spot improve image sharpness and spatial resolution, essential for detecting fine details diagnostic imaging. The second one, a larger actual focus spot split the heat generated by electron
coalization, preventing damage to the anode. Okay, the last one is limitation. One limitation of the line focus principle is the Hill effect, where X-ray intensity is reduced on the anode side of the beam due to absorption within angle target. This effect must be managed during positioning to ensure consistent image quality. Okay, in conclusion, the line focus principle is a cornerstone of the X-ray tube design. By angling the anode, it provides a smaller, effective focus point for a better image resolution while maintaining heat dissipation. That's all from me. Thank you.
Okay, hi, my name is Dahlia Zara binti Batarman. So I'm going to present about the anode Hill effect. So what is the anode Hill effect? The anode Hill effect describes the phenomenon where the X-ray beam is more intense on the cathode side of the beam, which is closest to the cathode, and less intense on the anode side, which is near the anode hill. This occurs because X-ray produced at the hill side of the anode travel through a thicker portion of the anode before exiting, resulting in higher attenuation, which is absorption and scattered of those X-ray. The cathode source X-ray travel through less anode material and experience less attenuation, making the radiation more intense. Okay, first, anode angle. How long the X-ray travel through the anode material depends on the anode angle, which is the X-ray tube anode target setting angle, usually between 7 degree and 20 degree. A greater phase difference between X-ray generated near the cathode and those generated at the anode hill result in steeper anode angle, intensifying the anode hill effect. Less attenuation of the X-ray from the anode hill side and a smaller phase difference result with shallower anode angles, which weakens the anode hill effect. Okay, next, source to image distance. In X-ray tube, the anode hill effect is influenced by the source to image distance, which is SID. The anode hill effect is more noticeable at shorter SID values. This implies that the closer source to image distance, which is SID, the contrast in intensity between the cathode and anode side of the X-ray beam can be more accurate. Okay, next, field size. In X-ray imaging, the anode hill effect can also be affected by the field size. Variation in X-ray intensity throughout the image may result from the anode hill effect being more noticeable when a larger field size is used. By removing X-ray from the anode and cathode sides of our field, a technique known as collimation, we can alter the size of our field. One advantage of field size that help lessen the anode hill effect is collimation. The X-ray tube and object being photographed can be positioned differently to lessen the anode hill effect and to reduce the effect of the anode hill effect on the X-ray imaging. On the X-ray image, use a smaller field size and increase the source to image distance, which is SID. In conclusion, last but not least, keep in mind that this modification may reduce the anode hill effect, anode angle, SID, and field size. That's all for me. Thank you.